In 1977, humanity fired a blind, desperate bullet into the dark. The Voyager 1 space probe has been tearing through the vacuum for nearly half a century, moving at a blistering velocity of 17 kilometers per second. To our localized terrestrial brains, it is a marvel of human engineering, currently sitting over 24 billion kilometers away, plunged into the freezing, uncharted waters of interstellar space. But if you strip away human pride and apply the cold, merciless mathematics of the cosmos, Voyager has achieved absolutely nothing. It is a microscopic speck of metal that has barely managed to scrape the paint off our own front door. If it were headed toward Proxima Centauri, the nearest star to our Sun, this crowning achievement of human velocity would not arrive for another 73,000 years. The universe is not merely large. That word is a biological comfort, a pathetic linguistic tool we invented to describe oceans or mountain ranges. The universe is an actively hostile architecture, built on a scale that is fundamentally designed to isolate and swallow everything within it. To understand the true, terrifying dimensions of reality, we must look at the absolute physical speed limit of causality itself. Light. Moving at 300,000 kilometers per second, a photon can circle the Earth 7 times in a single heartbeat. To a human being, this is indistinguishable from instant teleportation. But unleash that exact same photon into the deep void, and it is instantly paralyzed by the sheer volume of the abyss. To cross our own Milky Way galaxy, that blazing photon must travel in a straight line for 100,000 years. To reach the edge of the observable cosmos, it would need to fly through the expanding dark for 93 billion years. The incomprehensible expanse of space renders the fastest, most absolute force in nature agonizingly, suffocatingly slow. We are trapped in a machine where motion itself is practically meaningless. If you are willing to abandon the safety of your terrestrial instincts, if you seek a profound, unflinching understanding of the terrifying mechanics that govern our reality, subscribe and join us on this journey. We will not offer you comfortable illusions, only the brutal, awe-inspiring truth of the void. The cognitive dissonance we experience when trying to understand this scale begins the moment we attempt to map our physical reality onto the cosmos. For thousands of years, our ancestors looked up at the night sky and constructed a manageable, comforting diorama. They built imaginary spheres of crystal and assigned the stars to a fixed, permanent ceiling, wholly convinced that the limits of human sight were the absolute physical limits of creation. But the true horror of cosmic scale did not reveal itself through quiet philosophical pondering. It emerged slowly from the meticulous, chilling calculations of early astronomers who realized that the faint light hitting their primitive telescope lenses was carrying a mathematical plague. To comprehend the sheer hostility of cosmic scale, we must first dissect the fundamental biological lie that governs human perception. Your brain is a supreme survival engine, meticulously optimized by millions of years of evolution on the sunlit, terrestrial plains of a rocky world. You are a predator, built to calculate the distance to a fleeing animal, to judge the gap between two branches, to navigate a localized, three-dimensional environment. To achieve this, your biology utilizes stereopsis. The few centimeters of distance between your left and right eyes provide two slightly different images of the world, which your brain fuses together to create the illusion of depth. But this biological machinery has a hard, physical limit. Beyond a few hundred meters, your depth perception completely breaks down. Your eyes can no longer triangulate. Instead, your brain relies on context clues, atmospheric haze, and relative sizing to guess how far away a mountain or a cloud might be. When you stand in the dead of night and look up at the cosmos, you're looking into an environment utterly devoid of context clues. There is no atmospheric haze in the vacuum. There are no familiar objects to provide scale. Your stereoscopic vision is completely useless. Consequently, your brain defaults to the simplest, most biologically comforting interpretation. It flattens the universe. It processes the night sky as a massive, two-dimensional matte painting, a dark dome hovering just out of reach, with the stars physically pinned to its surface. You do not see depth, you see a ceiling. For the vast majority of human history, The brightest minds on Earth built entire civilizations upon this optical illusion. In the 2nd century, the Greek astronomer Claudius Ptolemy formalized the geocentric model of the universe, a cosmological architecture that perfectly mirrored human biological intuition. The Earth sat motionless and supreme at the dead center of reality. Surrounding the Earth were a series of nested, transparent crystalline spheres carrying the Moon, the Sun, and the planets in perfect harmonious circles. The outermost shell, known as the primum mobile, held the fixed stars. This universe was not a terrifying abyss. It was a cosmic terrarium. It was an intimate, tightly packed clockwork machine designed entirely for human observation. The physical distance to the outermost shell of stars was calculated to be a few million miles at most. To a human being, 1,000,000 miles is vast, but it is a manageable vastness. It is a number the mind can somewhat hold. It placed humanity at the bottom of a cosmic well, but a well with a solid floor and a visible physical roof. There was immense psychological comfort in this closed system. It meant the universe had boundaries. It meant we were safely contained. This comforting architecture was violently shattered in 1543, when a Polish astronomer named Nicholas Copernicus published his revolutionary heliocentric model. By moving the Sun to the center of the solar system and setting the Earth in motion, Copernicus solved the erratic, looping orbits of the planets with elegant mathematical precision. But in doing so, he inadvertently triggered a geometric nightmare that would haunt astronomers for centuries. If the Earth is not static, if it is actively hurtling through space in a massive orbit around the Sun, then our vantage point of the universe is constantly shifting. This shifting vantage point demands a physical consequence known as stellar parallax. To understand parallax, hold a single finger up in front of your face, close your left eye, then open it, and close your right. Your finger will appear to violently jump back and forth against the background of the room. The finger is not moving. Your perspective is moving. The distance between your two eyes creates a baseline for triangulation. Now, scale this geometry up to the cosmos. The distance between the Earth in the middle of summer and the Earth in the middle of winter is the diameter of our orbit around the Sun, roughly 300 million kilometers. That is the ultimate cosmic baseline. It is the distance between our two eyes. Therefore, as the Earth swings from one side of the Sun to the other, the relatively close stars in the night sky should appear to jump back and forth against the backdrop of the more distant stars. In the late 16th century, the great Danish astronomer Tycho Brahe, a man possessing the most precise naked-eye observational instruments in human history, set out to measure this jump. Night after freezing night, from his island observatory, Brahe meticulously mapped the positions of the stars. He looked for the geometric shift that the Copernican model demanded. He found absolutely nothing. The stars were completely, perfectly static. They did not shift by even the most microscopic fraction of a degree. Faced with this data, Brahe concluded that the Earth simply did not move. Copernicus had to be wrong. Brahe did not reach this conclusion out of religious dogma, but out of mathematical terror. He realized that if the Earth was indeed moving and the stars were not shifting, there was only one geometric explanation. The stars had to be pushed so unfathomably deep into the void that a baseline of 300 million kilometers was entirely irrelevant. If Copernicus was right, the space between the outermost planet and the nearest star was a yawning, incomprehensible wasteland of nothingness. Brahe's mind recoiled at the sheer inefficiency of it. He could not accept a reality where nature would tolerate such a monstrous, empty abyss. But the mathematics of orbital mechanics eventually proved undeniable. The brilliant Johannes Kepler, inheriting Brahe's data, cemented the motion of the planets. The Earth was moving. The crystalline spheres were completely shattered. The protective roof of the sky was ripped away, exposing humanity to an infinite, centerless expanse. Kepler himself wrote of the dark, dark night of the soul when contemplating the infinite void. He felt a profound physical vertigo, the realization that we were not safely contained but dangling blindly over a bottomless, indifferent ocean of freezing vacuum was a traumatic philosophical shock. Yet even as telescopes were invented, growing larger and more powerful, gathering more light and revealing millions of new stars. The abyss refused to yield its actual dimensions. For over 200 years after the invention of the telescope, no human being could measure the distance to a single star. They remained dimensionless points of light, mocking the greatest minds of the scientific revolution. The universe was expanding in the human mind, but its true scale remained locked behind a wall of inadequate engineering. The dam finally broke in 1838, inside the freezing dome of the Königsberg Observatory in Prussia. An astronomer named Friedrich Wilhelm Bessel decided to hunt the phantom of stellar parallax using an instrument of agonizing mechanical precision known as a heliometer. The heliometer was not a standard telescope. Its primary lens was physically sliced perfectly in half down the middle. By adjusting micrometer screws, Bessel could shift the two halves of the lens, creating a double image of the stars he was observing. By aligning the images and reading the microscopic adjustments on the screws, he could measure the angular distance between two stars with a level of precision that bordered on the impossible. Bessel did not point his instrument at the brightest stars, which might simply be massive rather than close. He targeted a dim, unremarkable star in the constellation Cygnus, known as 61 Cygni. He chose it because it was moving unusually fast across the background sky over the years, a cosmic tell that it might be hovering in our immediate neighborhood. For months, Bessel meticulously tracked 61 Cygni, fighting atmospheric distortion, the thermal expansion of his brass instruments, and the physical exhaustion of operating in the cold dark. And finally, the star shifted. The Earth swung through its massive orbit, and the star made a microscopic jump against the deep background. Bessel had captured the parallax, but when he calculated the angle of that shift, the number he produced completely destroyed the human framework of distance. The angle of parallax for 61 Cygni was 0.314 arcseconds. To visualize the sheer absurdity of this measurement, imagine plucking a single solitary hair from your head. Now take that human hair and place it exactly 3 kilometers away from you, across a dark, open plain. The physical width of that hair, viewed from a distance of 3 kilometers, is roughly the angle that Bessel measured in the night sky. That was the geometric triangle he was working with. A triangle with a base of 300 million kilometers, stretching out to a point so needle-thin it almost ceases to exist mathematically. When Bessel applied the trigonometry to this microscopic angle, the resulting height of the triangle, the physical distance to 61 Cygni, snapped into brutal focus. The star was approximately 100 trillion kilometers away. 100 trillion kilometers. It is easy to say the words. It is easy to write the zeros on a piece of paper, but the human brain physically cannot simulate that scale. We must break it down into units of biological time just to feel the weight of it. Imagine counting upward, 1 number per second, without ever stopping to sleep or eat. 1,000,000 seconds will cost you roughly 12 days of your life. A billion seconds will consume 31 years. To count to 1 trillion seconds, you would have to stand in the dark and count for 31,700 years. Civilizations would rise, crumble to dust and be forgotten. Mountains would erode, and you would still be counting. 61. Cygni was 100 times that number in kilometers. And this was not a distant galaxy. This was one of our closest, most immediate neighbors. This was the cosmic equivalent of the front porch. Astronomers realized that the kilometer was a pathetic, microscopic yardstick, completely useless for measuring the architecture of the void. They were forced to adopt a unit of measurement based not on physical length, but on the speed of the fastest entity in the universe. The light year, the distance a photon of light traveling at 300,000 kilometers per second can cover in 1 Earth year, roughly 9.4 trillion kilometers. Under this new terrifying metric, 61 Cygni was over 10.4 light-years away. When Bessel looked at that dim star through his fractured lens, he was not looking at the star as it existed in that moment. The light striking his retina had been traveling across the absolute zero of the vacuum for over a decade. He was measuring the physical geometry of a ghost, and what exists in those 10.4 light-years of space between our Sun and 61 Cygni, a sensory deprivation chamber of staggering proportions. The interstellar medium is a desert so profoundly empty that it makes the hardest vacuums created in human laboratories look like thick soup. In the space between the stars, you might find one single stray atom of hydrogen per cubic centimeter. So it is an ocean of silence, bathed in the lethal invisible radiation of cosmic rays, hovering just a few degrees above absolute zero. If you were cast adrift in this expanse, you would not merely freeze or suffocate, you would be swallowed by a scale of nothingness that actively defies the concept of physical presence. You would be a mathematical zero in an equation of infinite apathy. The measurement of 61 Cygni was hailed as a monumental triumph of human engineering and mathematics. We had finally touched the stars, but it was a Pyrrhic victory. It was the moment humanity definitively realized that we are biologically exiled from the universe we inhabit. We are trapped on a microscopic grain of silicate rock, staring across a gulf so unfathomably wide that our fastest spacecraft would require hundreds of thousands of years just to reach the nearest shore. And the terror of the parallax method is that it is fundamentally limited by our own geometry. As we look just a fraction deeper into the galaxy, the shifting angles become so unimaginably small, so hopelessly buried in the atmospheric noise and the quantum jitter of our instruments, that triangulation fails entirely. The geometric trick that Bessel used only works for the absolute closest layer of stars surrounding our Sun. Beyond that microscopic bubble, the stars become completely untethered from our trigonometry. We were standing on the beach of a dark, shoreless ocean, realizing that our most advanced measuring stick could only calculate the depth of the very first wave. To map the true, crushing abyss of the Milky Way and the millions of light-years of hostile vacuum that lay beyond it, astronomers would have to abandon geometry altogether. They would have to stop looking at the movement of the stars and begin dissecting the bleeding, fractured anatomy of the light itself. When triangulation failed, humanity was left completely blind to the depth of the cosmos. The parallax method had pushed our vision out to a pathetic 100 light-years, a microscopic bubble that barely encompassed our immediate stellar neighbors. Beyond that, the millions of stars painting the Milky Way were completely unmoored from our geometry. An exceptionally bright star could be a massive, blinding titan millions of light-years away, or a pathetic, dying dwarf hovering just outside our solar system. The lenses could not tell the difference. To pierce the deep void, astronomers had to abandon the physical measurement of space and learn how to autopsy the light itself. They had to find a mathematical rhythm hidden within the chaotic radiation of the night sky. The mechanism that finally shattered the limits of human perception was not discovered through a telescope, but inside a cramped, poorly lit room at the Harvard College Observatory in the early 20th century. It was found by Henrietta Swan Leavitt, a human computer employed to perform the agonizing, monotonous labor of analyzing photographic glass plates. Leavitt spent her days staring through a magnifying loupe at microscopic black smudges on chemical negatives, measuring the exact brightness of thousands of stars in a chaotic cluster known as the Magellanic Clouds. While the male astronomers of the era were obsessed with mapping the positions of the stars, Leavitt was meticulously hunting for anomalies in their behavior. She focused her attention on a specific, volatile class of stars known as Cepheid variables. These are not stable, comforting suns like our own. They are massive, dying thermodynamic engines that are fundamentally failing to maintain their structural integrity. Deep within their cores, a violent mechanical war is raging between the crushing inward pressure of their immense gravity and the explosive outward pressure of their nuclear furnaces. In a Cepheid, this war has entered a catastrophic, rhythmic oscillation. The physics of this failure are driven by a layer of ionized helium acting as a massive, suffocating valve inside the star. As the nuclear core burns, the radiation tries to escape, but the helium valve traps the heat. The star begins to choke on its own energy. The internal temperature and pressure violently spike, forcing the entire massive structure of the star to physically expand outward into the vacuum, swelling to monstrous proportions. But as it expands, the gas finally cools. The helium valve releases its grip and the trapped radiation blasts out into space in a blinding flash of luminosity. With the pressure released, gravity instantly reasserts its dominance, violently crushing the star back down. only for the helium valve to close again, restarting the catastrophic cycle. The star is literally gasping for air. It pulses, swelling and shrinking, dimming and brightening over a period of days or weeks. As Leavitt meticulously logged the pulsing rhythm of hundreds of Cepheids, she noticed a hidden, mathematical elegance beneath the violence. She discovered a flawless, unbreakable correlation between the time it took for a Cepheid to pulse and its absolute, true luminosity. The slower the pulse, the more fundamentally massive and bright the star actually was. Our star that took 30 days to complete its cycle was physically emitting thousands of times more energy than a star that took only 3 days. This single, elegant observation was the key to unlocking the true terror of the cosmos. Leavitt had discovered the standard candle. By simply using a stopwatch to time how long a distant star took to pulse, astronomers could now calculate exactly how bright that star truly was at its source. Once you know a star's absolute true brightness, and you compare it to how faint and ghostly it appears on a photographic plate on Earth, you can run a merciless mathematical equation based on the inverse square law of light dissipation. The result is the exact, undeniable physical distance to that star. Leavitt had transformed the chaotic two-dimensional dome of the sky into a massive, three-dimensional grid. She handed humanity the ultimate measuring stick, completely unaware that it was about to be used to permanently destroy the scale of our reality. Armed with Leavitt's mathematical key, the astronomical community turned its attention to the most baffling anomalies in the night sky, the spiral nebulae. For centuries, observers had noticed faint, glowing whirlpools of light scattered among the sharp pinpricks of the stars. The prevailing scientific consensus of the early 1920s, championed by the brilliant astronomer Harlow Shapley, held that the entire universe consisted solely of our Milky Way galaxy. It was a staggering structure, estimated to be 300,000 light-years across, a spinning disk of billions of stars. But it was everything. The cosmos was a single, isolated island of light, hovering in an infinite, empty sea. The spiral nebulae, Shapley argued, were simply small clouds of glowing gas churning inside the borders of our own galaxy. In 1923, an astronomer named Edwin Hubble set out to prove or disprove this theory. He gained access to the Mount Wilson Observatory in California, home to the Hooker telescope. This was a terrifying piece of industrial engineering, a 100-inch glass mirror weighing over 4 tons, suspended inside a massive steel cage that ground and whined as it tracked the sky. It was the most powerful optical instrument on the planet. Hubble pointed this massive cannon at the largest and brightest of the spiral nebulae, a glowing smear in the constellation of Andromeda. Night after freezing night, operating in the thin, biting air of the mountain peak, Hubble exposed fragile glass plates to the ancient light of Andromeda. He was not looking for gas. He was hunting for a pulse. He was looking for one of Leavitt's dying, gasping stars. On a plate dated October 6, 1923, amidst the chaotic swirl of the nebula, Hubble found a microscopic speck of light that varied in brightness. He crossed out his original notation with a red pen and wrote 3 letters, V1, variable 1. He had found a Cepheid variable deep inside Andromeda. Hubble meticulously tracked its rhythm. He timed the mechanical oscillation of the star's agonizing expansion and collapse. He applied Leavitt's law to calculate its true absolute luminosity, and then he ran the inverse square equation to find the physical distance required to dilute that massive amount of light into the pathetic, ghostly smudge on his glass plate. The number that emerged from Hubble's calculations did not just break the borders of the Milky Way, it annihilated the human conception of scale. The star V1 was not inside our galaxy. The mathematics proved that Andromeda was located roughly 2.5 million light-years away. The light hitting Hubble's cold glass plate had not originated centuries ago. It had begun its journey across the absolute zero of the void before the human species even existed. When those specific photons blasted out of the swirling plasma of Andromeda, Homo habilis was just beginning to strike stones together in the dust of the African continent. Those photons traveled in a straight line at 300,000 kilometers per second, entirely undisturbed, silently crossing an ocean of nothingness for 2.5 million years, completely indifferent to the rise and fall of every empire, every war, and every human tragedy on Earth, only to end their incomprehensible journey by striking a chemical emulsion on a glass plate in a freezing Californian observatory. Andromeda was not a cloud of gas. It was an island universe, another massive independent galaxy containing hundreds of billions of stars, completely separate from our own. In a single night, the universe expanded by a factor of millions. The Milky Way was instantly demoted. We were no longer the sum total of reality. We were merely one isolated, insignificant archipelago of matter, suspended in an ocean of unimaginable depth. The space between the galaxies, the intergalactic medium, makes the emptiness between individual stars look crowded. It is a sensory deprivation chamber so absolute that you could travel at the speed of light for thousands of millennia and never encounter a single atom of physical matter. It is a scale of isolation that the human brain actively rejects, a level of spatial apathy that borders on the physically hostile. But even this realization was only the first microscopic step into the abyss. As astronomers built larger and more sophisticated instruments, throwing wider nets into the dark, they realized that Andromeda was not a lonely neighbor. It was merely the closest shore in an archipelago of terrifying proportions. When you zoom out from the local group, the cluster containing the Milky Way and Andromeda, the true brutal architecture of the cosmos begins to reveal itself. Galaxies are not scattered randomly like dust motes in a sunbeam. The universe is structured. It possesses an anatomy. Through the merciless compound pull of gravity, operating over billions of years, galaxies are dragged into massive, glowing clusters. These clusters contain thousands of individual galaxies, each harboring hundreds of billions of blazing stars. The galaxies swarm around each other like angry insects, their gravitational fields ripping, tearing streams of stars from their neighbors, their central supermassive black holes cannibalizing the surrounding matter in a slow, agonizing cosmic churn. And even these massive clusters are not the end of the scale. They are merely the nodes, the bright intersections in a structure of incomprehensible magnitude known as the cosmic web. When you map the position of millions of galaxies, you do not see a uniform spread. You see a biological nightmare. The universe looks like the neural network of a decaying brain. Galaxies are strung together in massive, twisting filaments of light, rivers of thermonuclear fire stretching for hundreds of millions of light-years across the dark. Our Milky Way is located on the outer, insignificant fringe of one of these filaments. We belong to a massive supercluster known as Laniakea, a Hawaiian word meaning immense heaven. Laniakea is a sprawling, distorted continent of light containing over 100,000 individual galaxies. All of them, including our own, are being dragged through the dark by a terrifying gravitational anomaly at the center of the supercluster known simply as the Great Attractor. It is a region of space pulling the mass of 100,000 galaxies toward it at a velocity of 600 kilometers per second. We are caught in a cosmic riptide, falling endlessly toward a structure we can barely map, hidden behind the dust and gas of our own galactic disk. But the sheer crushing mass of the cosmic web is not the most disturbing aspect of its architecture. To truly understand the terror of the cosmic scale, you must look away from the glowing filaments. You must look at the empty spaces between them. Because gravity has spent 13.8 billion years pulling matter into these massive structures, it has systematically evacuated the surrounding regions. This process has created the cosmic voids. These are not merely patches of space with fewer stars. They are monumental, spherical deserts of absolute nothingness. The most terrifying of these regions is the Boötes void. It is a spherical expanse of space located roughly 700 million light-years from Earth. To comprehend its scale, imagine our Milky Way galaxy, a structure so large that light requires 100,000 years to cross it. The Boötes void is 330 million light-years in diameter. It accounts for a staggering 0.27% of the volume of the entire observable universe. Based on the average density of the cosmos, a region of space that massive should contain roughly 10,000 individual galaxies. It should be a thriving metropolis of matter. But when astronomers meticulously scanned the Boötes void, they found almost nothing. In an expanse of space that should house trillions upon trillions of stars, they have only identified around 60 isolated galaxies. It is a dead zone of incomprehensible proportions. If you were to teleport the Earth and our solar system into the dead center of the Bootes void, the night sky would not be speckled with the faint glow of distant galaxies. It would be an unbroken, perfect black. The void is so vast that had we evolved there, humanity would not have even known that other galaxies existed until the invention of the most powerful deep space telescopes in the 1960s. We would have believed with absolute mathematical certainty that our lonely, isolated galaxy was the only physical object in an infinite sea of absolute darkness. The existence of regions like the Bootes void forces us to confront the fact that the universe is overwhelmingly composed of hostile, empty space. Matter is a rounding error. Biological life, planets, stars, and galaxies are microscopic impurities in a machine designed to mass-produce nothingness. Yet, despite these massive pockets of emptiness, the sheer mathematical volume of the universe ensures that the total sum of matter is an incomprehensible number. The observable universe, the absolute limit of what we can physically see before the speed of light cuts off our vision, is a sphere 93 billion light-years in diameter. Within this sphere, astronomers estimate there are roughly 2 trillion galaxies. Take a moment to let the mathematics of that number crush your terrestrial intuition. 2 trillion galaxies. If you assume an extremely conservative average of 100 billion stars per galaxy, the total number of stars in the observable universe is 200 sextillion. That is a 2 followed by 23 zeros. To make this number physically felt, consider every single grain of sand on every beach, in every desert, and at the bottom of every ocean on Earth. The total number of stars in the observable universe outnumbers the grains of sand on our entire planet by a factor of 10,000. For every single grain of silica you can hold in your hand, there are 10,000 massive, blazing thermonuclear engines screaming in the dark. There are more stars currently burning in the void than there are words ever spoken, whispered or shouted by every human being who has ever lived throughout the entire history of our species. It is a scale that renders human existence mathematically irrelevant. We are not a grand central act in a divine play. We are an accidental byproduct of chemistry, clinging to a microscopic fragment of cooling ash, orbiting a painfully average star, drifting through the desolate outskirts of a single insignificant galaxy, lost amidst a swarm of 2 trillion others. But as we mapped this crushing scale, as we stared into the deep void and calculated the horrifying geometry of the cosmic web, a fatal, physics-destroying anomaly emerged from the data. We realized that this massive, terrifying architecture is not a static museum, it is an engine. And the deeper we looked, the more we realized that the machinery governing the movement of these galaxies was actively, aggressively breaking the fundamental laws of cause and effect. We mapped the immense scale of the cosmos, only to discover that the universe is utilizing that exact scale to violently tear its own anatomy apart. To understand the mechanics of this universal destruction, we must return to the freezing mountains of Arizona in the early 20th century, where the first cracks in the static universe began to physically manifest. Before Edwin Hubble used the Cepheid variables to shatter the boundaries of our galaxy, an astronomer named Vesto Slipher was quietly performing autopsies on the light of the spiral nebulae. Operating the massive telescope at the Lowell Observatory, Slipher was not measuring distance. He was dissecting the chemical anatomy of the light itself using a spectrograph. This device takes the faint glow of a distant astronomical object and forces it through a prism, breaking the light down into a rainbow spectrum. Because the fires of stars are fueled by specific chemical elements like hydrogen, helium, and iron, these elements leave a distinct measurable barcode across the spectrum. They absorb very specific frequencies of light, creating sharp, vertical black lines in the rainbow. By reading this chemical barcode, an astronomer can perfectly identify the exact composition of a star burning millions of light-years away. But as Slipher meticulously analyzed the photographic plates of the spiral nebulae, he encountered a terrifying anomaly. The dark vertical lines of the chemical barcodes were intact, but they were in the completely wrong mathematical positions. They had been systematically shoved away from their natural resting places and pushed violently toward the red end of the light spectrum. Slipher had captured the visual manifestation of a physical phenomenon known as the Doppler effect. If a sound-emitting object like a blaring siren is rushing toward you, the sound waves are physically compressed in front of the vehicle, driving the pitch into a high, frantic squeal. As the vehicle passes and speeds away, the sound waves are dragged out and stretched, causing the pitch to drop into a deep, low moan. Light operates under the exact same mechanical constraints. If a galaxy is hurtling toward us, its light waves are compressed, shortening their physical length and shifting their color toward the high-energy blue end of the spectrum. But if a galaxy is fleeing from us, the light waves are stretched, elongating the physical distance between the peaks of the wave, bleeding off their energy and shifting the color toward the low-energy red. When Slipher looked at the data, the conclusion was inescapable. Almost every single spiral nebula he observed was heavily redshifted. They were not merely drifting, they were fleeing. A decade later, Edwin Hubble took Slipher's velocity data and combined it with his own revolutionary distance measurements. Hubble plotted the exact physical distance of dozens of galaxies against the speed at which they were receding. The mathematical relationship that emerged from this graph is arguably the most brutal and consequential discovery in the history of human science. Hubble proved that the speed at which a galaxy is fleeing from Earth is directly and perfectly proportional to its distance from us. A galaxy that is twice as far away is moving twice as fast. A galaxy 10 times further out is fleeing 10 times faster. The relationship is linear, merciless, and absolute. This mathematical perfection could not be explained by a chaotic explosion of matter flying outward from a central point. If that were the case, the galaxies would be moving at random speeds depending on the localized violence of the blast. The perfect proportionality of Hubble's law demanded a far more disturbing mechanical reality. The galaxies themselves were not physically moving through space at all. The very fabric of space itself, the unseen three-dimensional grid of reality, was swelling. To grasp the true terror of this mechanism, you must abandon the idea of space as an empty box where objects move around. Space is a physical medium. Imagine a vast, infinitely long, perfectly black rubber sheet. Now imagine taking a white marker and drawing thousands of tiny dots scattered across the surface of the rubber. These dots are the galaxies. If you grab the edges of the sheet and pull, stretching the rubber uniformly in all directions, what happens to the dots? The dots themselves do not move. They remain absolutely stationary relative to the exact piece of rubber they are drawn on. But because the entire sheet is expanding, the physical distance between every single dot and every other dot steadily increases. And the mathematics of this stretching are cumulative. If every centimeter of the rubber sheet expands by just 1 millimeter per second, two dots that are close together will only separate slowly. But two dots that are separated by 100 miles of rubber will appear to fly apart at terrifying speeds, simply because there is a massive amount of stretching rubber sitting between them. We are one of those dots. And as we look out across the vast expanding rubber sheet of the cosmos, the cumulative addition of stretching space creates a mathematical paradox that violently breaks the absolute physical limits of reality. In 1905, Albert Einstein published his theory of special relativity, erecting the ultimate unbreakable barrier of the physical universe. Nothing, no particle of matter, no vessel, no transmission of data or gravitational ripple can travel through space faster than the speed of light. 300,000 kilometers per second is the absolute limit of causality. If you attempt to accelerate an object toward this boundary, the mathematics exact a terrifying toll. The object's mass begins to exponentially increase. The faster you push it, the heavier it becomes, requiring more and more energy to maintain the acceleration. To push an object possessing even the mass of a single electron completely to the speed of light would require an infinite amount of energy. It is a hard mathematical barricade that locks down the mechanics of the cosmos. But Einstein's later masterpiece, the theory of general relativity, contained a catastrophic loophole. The speed of light is the absolute speed limit for objects moving through space. But space itself is not an object. Space is the theater, and the laws of physics do not place a speed limit on the expansion of the theater itself. Astronomers measure the expansion of the universe using a value known as the Hubble constant. It dictates the exact rate at which the vacuum is multiplying. For every megaparsec of distance, which is roughly 3.25 million light-years, the swelling of space adds approximately 70 kilometers per second to the velocity at which a galaxy appears to recede from us. At a relatively close distance of 100 megaparsecs, the cumulative expansion means the galaxy is receding at 7,000 kilometers per second. It is a simple, compounding addition. But if you follow this arithmetic out into the deep void, it inevitably triggers a mathematical catastrophe. If you look far enough away, the sheer staggering volume of expanding space sitting between us and a distant galaxy becomes so immense that the cumulative rate of expansion violently crests 300,000 kilometers per second. This invisible mathematical perimeter is known as the Hubble sphere. It sits roughly 14.4 billion light-years from Earth in every direction. Beyond this exact boundary, the universe is multiplying so rapidly that the galaxies embedded within the fabric are receding from us faster than the speed of light. They are not violating special relativity. They are not firing massive engines to break the speed limit. They are completely stationary in their own local pockets of the vacuum, but the ocean of space between us and them is swelling at a superluminal rate. This superluminal expansion creates a temporal paradox that shatters human logic and explains the horrifying disparity between the age of the universe and its physical size. Modern cosmology dictates that the universe is roughly 13.8 billion years old. Intuition suggests that if the universe has only existed for 13.8 billion years and light can only travel at a set speed, then the absolute maximum distance we should be able to see is 13.8 billion light-years in any direction. The entire observable bubble should be 27.6 billion light-years across, but it is not. The true diameter of the observable universe is an incomprehensible 93 billion light-years. How can we see the light from a galaxy that is 46 billion light-years away? If the universe is only 13 billion years old, the light has not had enough time to make the journey. The answer lies in the treadmill of the expanding vacuum. When that extremely distant galaxy first fired its photons toward Earth, roughly 13 billion years ago, the universe was much smaller. The galaxy was physically much closer to us. The photons began their journey, traveling at the absolute maximum speed allowed by physics. But almost immediately, the space they were traveling through began to violently stretch beneath them. Imagine a runner attempting to sprint from one end of an airport, moving walkway to the other. But the walkway is moving in the opposite direction, and the walkway is made of rubber, and it is actively stretching, becoming longer and longer with every passing second. The photons were flying toward Earth at the speed of light, but the physical distance they had to cover was continually multiplying. They were forced to swim against a superluminal tide. For billions of years, the photons were actually losing ground. The expansion of space between the light and the Earth was occurring faster than the light could travel, pushing the light physically further away from us, even as it flew directly toward us. It is only because the expansion rate of the early universe was undergoing complex shifts in momentum that the light was eventually able to crawl its way over the mathematical hump, outlasting the most violent periods of expansion, and finally arriving at our telescope lenses 13 billion years later. But the galaxy that emitted that light is no longer where the light suggests it is. Over those 13 billion years, the superluminal expansion of the cosmos has carried the physical body of that galaxy far beyond the Hubble sphere, shoving it out to a staggering distance of 46 billion light-years. When we look at the deepest images of the cosmos, we are not looking at physical reality. We are looking at an optical illusion, a graveyard of phantoms whose physical bodies have long since been swept away by an impossibly fast cosmic tide. For decades, the astronomical community found a grim comfort in the assumption that this terrifying expansion was finite. They believed the universe was merely coasting on the residual kinetic energy of the Big Bang. Because gravity is an exclusively attractive force, the collective localized mass of the 2 trillion galaxies the dark matter halos, and the infinite spiderweb of cosmic dust should act as a monumental braking system. The combined gravitational tether of all the matter in the cosmos should be actively pulling backward against the swelling of the vacuum, slowly bleeding the momentum, suffocating the expansion. Physicists were absolutely certain that the expansion of the universe was decelerating. The only question left to answer was whether the gravity was strong enough to eventually stop the expansion entirely and drag the universe back into a catastrophic, crushing singularity, or if the expansion would simply slow down forever, coasting into infinity. In 1998, two fiercely competitive teams of astronomers set out to measure the exact rate of this deceleration. To do this, they needed standard candles that were billions of times brighter than Leavitt's Cepheid variables. They needed beacons powerful enough to pierce the deepest, most ancient edges of the visible void. They found their metric in the cataclysmic detonation of Type 1a supernovae. These specific stellar explosions occur when a dense, dead white dwarf star cannibalizes too much plasma from a companion star. Because the physics of a white dwarf dictate that it can only hold a very precise mathematical limit of mass before catastrophically collapsing, a boundary known as the Chandrasekhar limit, every single Type 1a supernova detonates at the exact same universal mass threshold. Because they detonate at the same mass, they explode with a nearly identical baseline peak luminosity. They are the ultimate standardized bombs of the cosmos. By utilizing the Hubble Space Telescope and a network of ground-based observatories, the teams hunted for these microscopic flashes of light at the very edge of time. By measuring how faint the explosions appeared, they calculated the exact physical distance to the dying galaxies. By measuring the severe redshift of the light, they calculated exactly how fast the fabric of space was stretching when the bomb went off billions of years ago. They plotted the coordinates on a graph, fully expecting to see the downward arching curve of a universe that was slowly grinding to a halt under the crushing weight of its own gravity. They expected to measure the friction of reality. When the data was finalized, the mathematical curve did not arch downward. It bent violently, aggressively upward. The expansion of the universe was not slowing down. It was speeding up. The astronomical community was thrown into a state of intellectual paralysis. It was a discovery so profoundly counterintuitive, so deeply hostile to the established laws of physics, that many scientists initially assumed the data was contaminated. But the mathematics held. Something invisible, entirely undetectable, and unimaginably powerful was operating within the absolute nothingness of the vacuum. It was a force that did not care about the gravitational bonds of 2 trillion galaxies. It was actively overpowering the combined mass of the entire universe, stepping relentlessly on the accelerator, driving the cosmic expansion into an exponential runaway reaction. Physicists named this horrifying anomaly dark energy. The name is a confession of absolute ignorance. It is a placeholder for a phenomenon we do not understand, cannot see, and cannot capture. But the cold, hard calculations dictate that this unseen pressure constitutes roughly 68% of the total energy density of the entire universe. All the physical matter we can see, every star, every black hole, every planet, and every biological organism, accounts for barely 5% of reality. We are a microscopic dusting of debris floating inside a machine powered by an engine we cannot comprehend. The leading theoretical explanation for dark energy is a concept that resurrects a discarded mathematical hack once used by Albert Einstein, the cosmological constant. It posits that perfectly empty space is not actually empty. The vacuum itself possesses an inherent repulsive pressure. It is a fundamental property of the grid, and this creates a catastrophic, inescapable feedback loop. As the universe expands, it creates more physical volume. It creates more empty space. Because this repulsive energy is an intrinsic property of the space itself, creating more space creates more dark energy. As the amount of dark energy multiplies, it pushes the universe to expand even faster. The faster it expands, the more space is created, spawning even more dark energy. It is an infinite, compounding cycle of geometric violence. The universe is actively weaponizing its own emptiness against the matter trapped within it. When the greatest minds in theoretical physics attempted to calculate the actual mechanics of this vacuum energy using our most successful mathematical model, quantum field theory, they triggered what is widely considered the most humiliating mathematical failure in the history of science. Quantum mechanics dictates that the vacuum is a boiling, chaotic sea of virtual particles constantly erupting into existence and annihilating each other in fractions of a microsecond. This quantum static should give the vacuum a specific calculable baseline of energy. Physicists ran the quantum equations to predict how much energy the vacuum should hold, hoping it would perfectly match the repulsive force of the dark energy observed by the supernova data. They arrived at a number. They then compared their theoretical prediction to the actual physical reality of the accelerating cosmos. The numbers did not match. The theoretical prediction from quantum mechanics was larger than the actual observed dark energy by a staggering factor of 10 to the power of 120. That is a 1 followed by 120 zeros. It is an error so colossal, a discrepancy so mathematically absurd, that the human mind has no framework to even process the scale of the failure. It means that our two most rigorously tested, highly successful pillars of reality, the quantum mechanics that govern the microscopic world and the general relativity that maps the cosmic architecture, are locked in a fatal, fundamentally irreconcilable contradiction. When we attempt to calculate the very force that is actively tearing the universe apart, our absolute best physics shatter into useless fragments, and the fracture in our understanding of reality is actively widening. Today, modern cosmology is engaged in a bitter existential crisis known as the Hubble tension. As our orbital telescopes and deep space sensors have become unimaginably precise, we have developed two separate, highly accurate methods for measuring the exact speed of the universe's expansion. The first method looks backward, observing the cosmic microwave background radiation. This is the literal thermal afterglow of the Big Bang, a faint wall of microwave static ringing the entire observable universe. By mapping the microscopic temperature fluctuations in this ancient radiation, physicists can calculate the exact density and physics of the infant universe and then use our standard cosmological models to project the expansion rate forward to the present day. The second method looks at the local, modern universe. It uses the James Webb Space Telescope to hunt for Leavitt's Cepheid variables and Perlmutter's supernovae in relatively nearby galaxies, manually calculating the expansion rate happening right outside our galactic door. Both methods are backed by decades of peer-reviewed data. Both methods rely on the most rigorously tested physics in human history, but when astronomers compare the final numbers, they refuse to align. The early universe calculation predicts a significantly slower expansion rate. The late universe observation measures a significantly faster one. For years, scientists hoped this was merely a calibration error, a smudge on the lens. But as the instruments improved, the error bars shrank, and the gap between the two numbers only solidified. The statistical probability of this being a mere observational mistake has dropped to 0. The data is screaming at us. The universe is expanding significantly faster than our absolute best laws of physics say it mathematically should be. The standard model of cosmology is missing a massive, critical piece of machinery. There is an unknown physics operating in the dark, a phantom mechanism that is actively altering the parameters of reality as the universe ages. This terrifying acceleration forces us to confront the true physical consequence of the expanding barrier. Because the universe is hitting the gas pedal, the Hubble sphere, the boundary where space begins to recede faster than the speed of light, is not static. The superluminal barrier is moving, and it is not moving outward. As dark energy pumps more and more repulsive pressure into the void, driving the expansion faster, the exact distance at which space exceeds the speed of light is being pulled closer and closer to Earth. The cosmological event horizon is actively shrinking around us. This is the absolute most terrifying paradox of the cosmos. The universe is infinite, and yet our physical reality is being systematically suffocated. Every single second that ticks by on your watch, the accelerating expansion of the vacuum pushes thousands upon thousands of distant stars across the event horizon. When a galaxy is pushed over this mathematical cliff, it enters a region of space that is receding from us so unfathomably fast that the light it emits at this exact second will never, under any circumstances, reach the Earth. Even if you possessed a spacecraft capable of traveling at 99.9% the speed of light, you could chase that galaxy for 1 trillion years and you would never close the gap. The space between you and the target is multiplying faster than you can ever traverse it. The bridge is burned. The mathematical connection is permanently, violently severed. We are standing on a microscopic island of matter, watching the tide of the vacuum rise. The universe is actively outrunning its own light, dragging the physical evidence of its existence out of our reach, and preparing the absolute isolation of everything we know. To fully comprehend the physical weight of this isolation, you must understand that the universe is currently engaged in a massive, silent war of fundamental forces, and gravity is losing. On a local scale, gravity is a tyrannical force. It dictates the orbits of planets, ignites the cores of stars, and binds massive collections of matter together. But gravity is highly dependent on proximity. As the physical distance between objects increases, the strength of their gravitational attraction drops exponentially. Dark energy, however, does not care about proximity. It is a property of the vacuum itself. It is ubiquitous, relentless, and it scales directly with volume. Where gravity attempts to pull matter together into localized, glowing islands, dark energy seeks to push the very fabric of the ocean apart. And because the universe is overwhelmingly composed of empty space, dark energy has the ultimate mathematical advantage. Right now, our Milky Way galaxy is anchored by gravity to a small collection of neighboring structures known as the Local Group. This includes the Andromeda Galaxy, the Triangulum Galaxy, and roughly 50 dwarf satellite galaxies. Within this specific, localized pocket of space, gravity is still strong enough to overpower the repulsive expansion of the vacuum. We are gravitationally bound to Andromeda. In fact, we are falling toward it at over 100 kilometers per second. In approximately 4 billion years, long after our sun has scorched the Earth into a lifeless cinder, the Milky Way and Andromeda will collide in a catastrophic gravitational dance. Because the physical space between individual stars is so unimaginably vast, very few stars will actually crash into one another. Instead, the galaxies will pass right through each other like ghosts, their massive gravitational fields ripping, tearing streams of stars from their spiral arms. They will swing back around, collide again, and eventually their central supermassive black holes will merge in a violent ripple of space-time. The resulting chaos will trigger a blinding firestorm of new star formation, forging a single, massive, elliptical supergalaxy. This future supergalaxy will be our final, impenetrable fortress against the dark. It will be a gravitational bunker holding out against the rising tide of the vacuum. Because outside the borders of our local group, the war is already over. Every other galaxy, every other cluster, every single structure in the visible universe beyond our immediate neighborhood is currently being swept away by the accelerating expansion, and they will not just fade quietly into the distance. The mechanics of their disappearance involve a terrifying manipulation of time itself. As a distant galaxy is pushed closer to the cosmological event horizon, the space between us and it expands at near light speed. According to the absolute laws of relativity, this extreme velocity begins to warp the flow of time. From our perspective on Earth, as we watch that galaxy approach the absolute edge of the observable universe, we will see its internal clock begin to violently slow down. The orbits of its stars will appear to crawl. The detonation of its supernovae will stretch from weeks into centuries. The light it emits will be stretched into longer and longer wavelengths, dropping rapidly through the infrared, down into microwaves, and finally into ultra-low frequency radio waves. When the galaxy finally crosses the superluminal threshold, it does not simply vanish in a puff of smoke. It freezes. The last photons it emitted before crossing the horizon will be stretched to mathematical infinity. The galaxy will become a frozen, invisible ghost, a permanent fading imprint on the absolute edge of our reality. Over the next 100 billion years, every single galaxy outside our local group will undergo this exact process. They will all hit the boundary, freeze, and fade into completely undetectable wavelengths. The sky will be meticulously, systematically wiped clean of all external light. This physical erasure leads to a consequence that is far more terrifying than mere darkness. It is the permanent, irreversible deletion of cosmic history. Science is fundamentally built on the premise of observation. We understand the origins of the universe because we can look deep into the void and see the physical evidence. We can see the red-shifted light of fleeing galaxies, which proves the universe is expanding. We can point microwave antennas at the sky and detect the cosmic microwave background radiation, the literal thermal afterglow of the Big Bang itself. This faint static is the ultimate proof that our universe was once a microscopic, infinitely hot singularity. But as dark energy accelerates the expansion of space, it is actively stretching that evidence into oblivion. In 1 trillion years, the physical wavelength of the cosmic microwave background will be stretched so severely that a single wave of radiation will be physically larger than the entire observable universe. It will be completely impossible to detect by any physical instrument, no matter how advanced the engineering. The thermal footprint of creation will be permanently erased from the crime scene. Simultaneously, the accelerating expansion will have pushed all other galaxies so far beyond the horizon that the night sky will be completely empty. There will be no fleeing galaxies left to measure, no Doppler shift to calculate, no visual data whatsoever to suggest that the universe is or ever was expanding. Imagine an intelligent civilization that rises from the ashes of a dying star within our merged super-galaxy 1 trillion years from now. Their scientists will be just as intelligent, just as curious as ours. They will build magnificent telescopes and formulate flawless mathematics. But when they point their instruments into the dark, they will see absolutely nothing but the stars of their own local galaxy. They will look for the afterglow of a Big Bang, and they will find zero thermal evidence. They will look for the expansion of space, and they will measure a perfectly static, silent void. Based entirely on the absolute best empirical evidence available to them, these future scientists will logically and flawlessly deduce that their single, isolated galaxy constitutes the entirety of reality. They will believe that the universe is static, unchanging, and infinite. They will believe exactly what humanity believed in the Dark Ages. The physics of the vacuum will enforce an inescapable epistemological trap. The ultimate consequence of dark energy is not just the physical isolation of matter, but the isolation of truth. The universe is actively burning the bridge to its own past. We are living in a temporary, highly privileged window of cosmic time where the evidence of creation is still faintly visible. We are the lucky few who get to know the truth before the universe permanently buries it in the dark. But the tragedy of the cosmos does not end with the loss of history or the isolation of galaxies. The terrifying scale of the universe is not merely a geometric trick of expanding space. It is a profound, unyielding thermodynamic destiny. The universe is an engine, and all engines eventually run out of fuel. The blazing stars that currently illuminate our local galaxy, and the trillions of galaxies beyond, are not eternal fixtures. They are finite mechanical furnaces performing a very specific, temporary function. They are converting light elements, primarily hydrogen and helium, into heavier elements through the violent process of nuclear fusion. But this process is a one-way street. Once a star fuses its core into carbon, oxygen, or iron, that material is locked away. It becomes dead weight. The raw material required to build new stars, the vast swirling clouds of interstellar hydrogen, is a strictly finite resource, and the universe has already burned through the vast majority of its supply. Astrophysicists have measured the cosmic star formation rate across deep time, and the results are incredibly grim. The absolute peak of cosmic star production occurred roughly 10 billion years ago, during an era known as cosmic noon. Since then, the birth rate of stars across the universe has plummeted by over 95%. The cosmos is no longer an active, thriving nursery. It is an aging population. We are living in the late autumn of the stelliferous era, the brief, highly improbable period in cosmic history where stars are allowed to shine. As the eons drag on, the remaining hydrogen will be consumed. The massive, brilliant blue stars, which burn their fuel with reckless intensity, will detonate into supernovae and vanish within millions of years. The medium-sized yellow stars, like our Sun, will swell into red giants, incinerate their inner planets, blow off their outer layers, and eventually collapse into incredibly dense glowing embers known as white dwarfs. The only stars left will be the red dwarfs. These tiny hyperdense stars burn their fuel at a microscopic rate, hoarding their hydrogen for trillions of years. They will become the final outposts of light and warmth in a suffocating galaxy. But even they are bound by the absolute laws of thermodynamics. Eventually their fires will go out. When the last red dwarf exhausts its final atom of hydrogen, the universe will undergo a fundamental phase transition. It will enter the degenerate era. The cosmos will be littered entirely with stellar corpses. White dwarfs, neutron stars, and black holes will be the only physical structures left in the void. For a time, the white dwarfs will provide a pathetic residual glow. They are spheres of compressed carbon and oxygen, roughly the size of the Earth, but containing the mass of a sun, burning not with nuclear fusion, but merely radiating the trapped ambient heat of their violent past. But the vacuum is incredibly cold. Over unimaginably vast timescales, tens of quadrillions of years, these white dwarfs will slowly bleed their thermal energy into the expanding nothingness. Their temperatures will drop fraction by fraction until they match the absolute zero of the surrounding void. They will crystallize into black dwarfs, silent, frozen, invisible spheres of degenerate matter, completely indistinguishable from the blackness that surrounds them. The neutron stars, the ultra-dense cores of collapsed giants, will suffer the exact same fate, their furious magnetic fields dying away, their rotations slowing to a complete halt, turning into cold, dead iron spheres. The darkness of the night sky will transition from a trick of geometry into a literal physical reality. The engines of light will be completely dismantled. In this unfathomably distant future, the only objects holding any significant mass or energy will be the black holes. They will sit in the dead centers of frozen galaxies, surrounded by a swirling invisible graveyard of black dwarfs and dead planets, silently waiting in the absolute dark. But the ruthless mechanics of quantum physics dictate that even black holes cannot survive the deep time of the cosmos. Through a process mathematically proven by Stephen Hawking, black holes slowly leak quantum radiation. They evaporate. The mathematics reveal a merciless truth. The smaller the black hole, the hotter it burns, accelerating its own evaporation into the void. Over timescales that require a 1 followed by 100 zeros to express, even the supermassive black holes that anchor the galaxies will bleed out, their event horizons shrinking millimeter by millimeter until they detonate in a final microscopic flash of gamma radiation before dissolving into perfectly empty space. We have constructed our entire philosophical framework upon a desperate biological illusion. We look up into the night sky and perceive a ceiling, a canopy of eternal fixtures that offers a false sense of permanence. We take comfort in the idea that long after we are gone, the stars will remain, bearing silent witness to the memory of our existence. But the mechanical reality we have uncovered dictates a far more brutal truth. The universe is not a witness, it is an eraser. The terrifying scale of the cosmos is not merely a spatial dimension. It is a temporal weapon, actively sweeping the physical evidence of our reality into a mathematically unreachable abyss. Humanity emerged in a staggeringly brief, statistically improbable window of cosmic time. We arrived late enough for the violent, dying stars to have forged the heavy elements necessary for our biology, yet early enough to still see the ancient, stretched light of distant galaxies before they are permanently pushed beyond the superluminal horizon. We are the momentary observers stationed at the very edge of the dark, granted a fleeting glimpse of the cosmic architecture just before the lights are systematically turned off. We exist as a microscopic dusting of carbon and water, clinging to a fragment of silicate rock that is currently plummeting through an architecture so vast it breaks the mathematics of human comprehension. The millions of light years that separate the glowing filaments of the cosmic web and the hundreds of millions of light years of absolute nothingness that define the great voids render our entire biological history a mathematical zero. Every empire we have built, every war we have fought, and every god we have worshipped has occurred within a localized bubble of space so insignificantly small that the universe does not even register its existence. There is no grand, underlying purpose hidden within the machinery of the void. The merciless equations of astrophysics do not accommodate human intuition or our pathetic desire for meaning. The geometric dilution of the inverse square law, the violent stretching of the Doppler shift, the relentless exponential acceleration of dark energy, these are blind, unfeeling mechanisms. They execute their functions with absolute lethal precision. They are actively tearing the fabric of reality apart, outrunning their own light, and methodically exhausting the finite reserves of thermonuclear fuel that briefly held the darkness at bay. We spent centuries grinding massive, perfectly curved glass lenses and launching billion-dollar digital sensors into the freezing vacuum, desperately trying to fill the empty spaces with data, seeking reassurance that we were part of a connected, populated whole. But the deeper we looked, the more aggressively the universe asserted its fundamental hostility. It showed us a sky saturated with the blazing fires of 2 trillion galaxies, only for the physical expansion of space to instantly render them completely invisible to our eyes. The universe is actively, relentlessly hiding its true face, stretching its own history into an undetectable phantom. The paradox of the dark sky is finally resolved, not with a comforting physical barrier, but with a mathematical sentence of absolute, inescapable solitude. The blackness between the stars is the encroaching shadow of the cosmological event horizon. It is the visual manifestation of space expanding faster than the speed of information, a slow, methodical, and completely unstoppable quarantine of physical matter. The next time you step into the dead of night, do not look for the familiar, comforting shapes of the constellations. Do not look at the fading light. Look directly at the suffocating blackness behind them. Stare into the empty spaces. That absolute silence is not peaceful. It is the physical sound of the universe evaporating into the void. It is the shadow of absolute zero, a silent, infinite ocean of degenerate matter, patiently waiting for the very last fires to finally burn out. Description. The night sky is a comforting optical illusion. When we look up, we perceive a static, peaceful canopy of stars. But the sheer, terrifying scale of the cosmos hides a brutal mechanical reality. The universe is actively tearing its own architecture apart. From the superluminal expansion of the vacuum driven by dark energy to the incomprehensible emptiness of the cosmic voids, the darkness between the stars is not simply empty space. It is the physical manifestation of an expanding event horizon that is systematically isolating every galaxy in existence. We are watching the cosmos evaporate into absolute zero. If you enjoy what we do here, hit like and subscribe. It genuinely helps. Sources: A. NASA. Science: What is dark energy? https science.nasa.gov Dark energy. B. Hubble site: The expansion of the universe. https hubblesite.org Contents articles: The expansion of the universe. C. Wikipedia: Boot is void. https n.wikipedia.org Wiki: Bo% C3% B6Ts void.